My dear students, in this video, in the topic permutations, I am going to derive the formula for nPr, number of permutations of n things taken or at a time. nPr means number of permutations of n different things considering or at a time, or things at a time. That is nPr. And we have to derive the expression for nPr. And in the last video, we can find 4p3. The value of 4p3 is number of permutations out of 4 different things. We have to take 3 things and that should be arranged. How many permutations are there for 4p3? That is 4 into 3 into 2. That is, if you find 3 numbers should be subtracted from 4. 4 minus 1, 4 minus 2 and so on. If you find 4p3, that is 4 into 4 minus 1, 3 into 4 minus 2, 2 like that. If you find 3 numbers should be there. Suppose 4p2, if you find 2 here, only 2 numbers should be right. 4 and 4 minus 1, 3. It is 12. This is 24 and so on, like that. Suppose 8p4, here number of permutations of 8 things taken, 4 things at a time. Considering 4 at a time, out of n different things, the number of permutations are 8 into 7 into 6 into 5. Since we are finding 4 here, we have to write 4 numbers. From 8, we have to write 4 numbers by subtracting 8 minus 1, 8 minus 2, 8 minus 3. See, this can be expressed as 8 into 8 minus 1 into 8 minus 2 into 8 minus 3. If you find 4, you find 3, 8 minus 3 only the last number. Similarly, for 4p3, 4 into 4 minus 1 into 4 minus 2. 4 minus 2 is 2, 4 minus 1 is 3, 4 into 3 into 2. If you find 3 here, you have to write 4 minus 2 in the last term. Like that, the terms will be expressed. See, 4p, 3, 8p, like that, I am going to now define nPr. Number of nPr means nPr. It means number of permutations of n different things, n different objects or things, n different objects taken or at a time, or things at a time, or objects at a time, or objects at a time. This is nPr. So by the rule of like the multiplication, nPr is, you know, first number n, next one is n minus 1, next term n minus 2, and n minus 3, and so on, etc. Last term is n minus 3. If it is 4, you get 8 minus 3. If it is 3, you get 4 minus 2. The last term should be less than the term or 3. Like that, n minus 1 and n minus 2 and n minus etc. n minus 1 or minus 1. Because if you find r object, the last term is r minus 1 only. Then only the terms are r objects are here. R arrangement, 1, 2, 3, 1. N is 1, 1, 2, 3, 4, etc. R terms. Totally, we are getting R terms here. nPr means n into etc. n minus 1 into R terms. R terms means half the term is n minus r minus 1. Okay. See, you can write it as here If you find 3, 3 terms. If you find 4, 4 terms. If you find 2, 2 terms. Like that, if you find R, you get R terms. Just you get R terms. The rth term is n minus R minus 1. If it is 3, 4 minus 2. If it is 4, 8 minus 3. Like that, the last term is n into n minus 1 into n minus 2 into n minus 3, etc. The R term is n minus R minus 1. Last term is n minus, since R is here, one term should be subtracted from R, that is the last term, n minus of R minus 1. The bar indicates R minus 1 is a single unit, n minus R minus 1. Or otherwise, again write it as n into n minus 1 into n minus 2 into n minus 3, etc. N minus, if you bring this minus inside if you remain in the bar, you will get n minus R minus or minus plus 1. That is the last term. So, the nPr value is n into n minus 1 into n minus 2, etc. n minus R plus 1. Here, n and R are positive integers. N and R are positive integers. N and R are positive integers. 4, 3, like that, 8, 4, like that. N and R are positive integers. And n should be greater than 1, greater than or equal to 1. N should be greater than or equal to 1. And R should be greater than or equal to 0, but less than or equal to n. I already told you, R should be positive, but less than or equal to n. N is always greater, because n is always greater. 4 greater than 3. 8 greater than 4, like that. The rth term should be greater than the nth term. N is always greater than R. We can select 4 things out of 8 things. We cannot select 8 things out of 4 things. 4p8 is not possible. 8p4 only possible. Therefore, n is always greater than R. N is greater than or equal to R, and R is greater than or equal to 0. R is positive. N and R are originally positive integers. We should not consider the negative integers. Like that, nPr is defined. From this expression, I am going to derive the formula for nPr. Okay? See, I am going to derive the formula for nPr now, where n and R are positive integers, and n is greater than or equal to 1, and R is greater than or equal to 0, but less than or equal to n. R is less than or equal to n, and greater than or equal to 0. That means R is positive always. N should be always greater than or equal to 1, greater than or equal to 1. So nPr is, we have to derive the formula for nPr. By the definition, nPr equal to n into n minus 1 into n minus 2 into n minus 3, etc. Last term is n minus R plus 1 by our idea. N minus R minus 1, but if you bring that minus inside the bar, you will get n minus R plus 1 is the last term. And I am going to adjust the numerator n minus 2, etc. n minus R plus 1. And the next term I am going to introduce n minus R plus 1. If I am subtract 1, I will get n minus R. If in n minus R plus 1, I am reducing 1, I will get n minus R. And next term n minus R minus 1. And next term n minus R minus 2. Like that, you extend the last term 3 into that last term, etc. If you consider like that, the last term is 3 into 2 into 1. Final term. Okay. After reducing from n, last term becomes 3, 2, This is your nPr term. I am introducing after n minus r plus 1, I am writing n minus r minus etc. so on up to 1. So, since I introduce the n minus r terms in the numerator, to balance that, I am introducing the denominator also the terms n minus r minus 1, n minus r minus 2, etc. 3, 2, 1. So, both in the numerator and denominator, I am introducing these r minus 1 terms, numerator and denominator, to balance to balance this expression. From the numerator, I can write 1 into 2 into 3 into etc. up to n only you have. Therefore, the numerator is n factorial. Numerator is starting from n, ends with 1. Therefore, the product is n factorial. The numerator is starting with 1, ends with n minus r. Therefore, the denominator is n minus r factorial. So, this is the formula for nPr. nPr equal to n factorial by n minus r factorial. This is the formula for nPr. nPr equal to n factorial by n minus r factorial. This is the formula for nPr, where n is greater than or equal to 1, r is positive, and that should be less than or equal to n. R should always be less than or equal to n. Okay. Now, I am going to define this nPr is n factorial by n minus r factorial. This is the formula. By the functional idea, I can write nPr equal to n factorial by n minus r factorial. This is the value of nPr where for r is less than or equal to n. If it is 0, for r greater than n. If r is greater than n, the value of the permutation is 0. For example, you know 8p3 is equal to 8 factorial by 8 minus 3 factorial. By the definition, nPr equal to n factorial by n minus r factorial. N equal to 8, r equal to 3. Therefore, nPr equal to n factorial by n minus r factorial. That is equal to 8 factorial by 5 factorial. This is for example. Using one idea of nPr, nPr equal to n factorial by n minus r factorial. R is 3, n is 8. Therefore, 8 factorial by 8 minus 3 factorial. 8 minus 3 is 5. So, nPr 8p3 is 8 factorial by 8 minus 3. 8 factorial by 5 factorial. 1 to 5 you get cancelled both in the numerator and denominator. You will get only 8 into 7 into 6 only. 5 factorial both numerator and denominator get cancelled. You will get 8, 7, 6 only. That's all the idea. Suppose 3p8. In this case, r is greater than n. In the case, r is greater than n. R should be greater than n. 3p8 is 0. There is no permutation. We cannot find permutation for 8 things from the 3 things. We cannot arrange 8 things from the 3 things. So it should not be possible. Therefore, this is 0. So this is the definition of nPr. Next, I am going to give some properties of nPr. Okay? See, now we derive the formula for nPr. nPr equal to n factorial by n minus r factorial I have given. See, from this idea, here r is greater than or equal to n and n is greater than or equal to 1. That is the idea. And I gave one example 8p3, that is 8 factorial by 8 minus 3 factorial, because n is 8, r is 3. This is 8 factorial by 8 minus 3, 5 factorial we have seen. Now, from this case, what is n phi n factorial? What is npn? Number of n things taken n at a time. All the n different things are considering n time. Each and every permutation containing n things. The total things are also n. out of n different objects, how many permutations are there, taken all the n things at a time. Okay, so suppose 5 students are there, we are considering all the 5 students 5 times. That is 5p5. I am asking the value. You know, since it is the 5, we are suppose n and r should be equal. R should not be greater than n, but should be equal, maybe equal. So r is greater than or equal to n. N is greater than or equal to r. Okay. R should be greater than or equal to n. So 5p5 is what? You will see. npn is n factorial by n minus r is n. R is r also n minus n factorial by formula nPr is n factorial by n minus r factorial. Using this formula, npn is n factorial by n minus n factorial. You treat it as a note for that. N factorial by n minus n is 0. 0 factorial, you know, 1. So n factorial divided by 1 is n factorial. So npn equal to n factorial. Since n and r are equal, it is n factorial. Similarly, 5p5 is 5 factorial. By definition, 5 factorial by 5p5 is 5 factorial by 5 minus 5 factorial. That is 5 factorial by 5 minus 5 is 0. 0 factorial is 1. 5 factorial by 1 is 5 factorial. So 5p5. If both r and n are equal, that is n factorial is the formula. Because mathematically you can derive 5p5, you know, you reduce 5 numbers from 5. 5 into 4 into 3 into 2 into 1. We have to reduce 5 numbers from 5. 5 minus 1, 5 minus 2, 5 minus 3, 5 minus 4. 5 minus 4 is 1. 1 into 5 is nothing but 5 factorial. So mathematically we can derive all, if n and r are equal, it is factorial time of n. That is our first idea. You remember that? Similarly, you know, 8p8 is what? 8 factorial. Like that, we will consider the idea of nPr. And we will proceed the properties, furthermore properties in our next video. Properties of nPr we will see in our next video also. Okay, thank you.